What's going on, brothers and sisters? I am your host, your brother, your professor, Mr. O'Neill Barnaby, founder and director of the Black Math Academy, here with another video showing you guys what intelligent black society is all about. So for the next few videos, I'm going to be creating a series where I'm going to be talking about some tips, some tricks, and some alternative methods to go about understanding and solving mathematical concepts a bit easier. So that when you get back to school, whether you're doing your homework or your classwork, your tests and quizzes, your projects, standardized tests, or even in the real world, you'll be able to have these things at your disposal so that it'll make your life a bit easier. Like Edna Mode once said in the movie The Incredibles, fortune favors the prepared. All right, let's get down to business. So what we're going to be talking about today, as you can see, is the GCF and the LCM. GCF stands for greatest common factor, and LCM stands for lowest common multiple. Right, so where are these things even useful? So the greatest common factor is useful for when you're trying to reduce a fraction. If the fraction needs to be reduced, you have to do it, and if they both have a common factor, you want to use that to be able to make the fraction simpler. And once it's simple, you can then use it easier in whatever problem you're trying to solve. The greatest common factor is also useful for when you're trying to factor out a polynomial equation or expression. All right, so you have like an expression that has multiple terms in them, and if each term has a common factor, you could pull it out, which is called factoring, and it'll make the expression or equation a bit easier to handle, and then you can solve it in a more simple fashion. Lowest common multiple is useful for when you're trying to add or subtract fractions. Because you need a common denominator to do that, the phrase common denominator is synonymous with lowest common multiple. They're both the same thing. All right? So, how do you go about finding the GCF and the LCM? Well, what you're going to be using is the factor tree. The factor tree splits numbers down into specifically its prime factors, and you're going to be using those to figure out what the GCF and the LCM actually is. So, we have to define what prime is. Well, a prime number or a prime factor is a number that only has two factors, one and itself. What they don't teach you in school, though, is that there's an addition to that definition where the two factors, the one and itself, actually have to be distinct numbers. Distinct is another way of saying different. So people think that the number 1 is a prime factor or a prime number, but in actuality, it's not. Because the two factors of 1 are 1 and 1, and because they're both the same number, the number 1 is not actually a prime number. The two factors actually have to be different. So another way to interpret that, or another way to say that, is that the two factors, one of them is 1, and the other one has to be bigger than 1. So prime, definition of prime is that one factor is 1, and the other factor is bigger than 1. So that one of them is 1, and the other one is bigger than 1. Let me put a y instead. So x times y. So one factor is 1, and the other factor is bigger than 1. That's what a prime number is. All right. So we're going to use the factor tree to split these two numbers, 210 and 720, into its prime factors, and we're going to use those to figure out what the GCF and LCM are. So 210, that value gets split into 21 and 10. 21 gets split into 7 and 3. 10 gets split into 5 and 2. And since 7, 3, 5, and 2 are prime numbers or prime factors, that's where we would stop, because if we couldn't split the number any further, so we would stop here. And here is where I like to circle my prime factors so that I know which numbers I'm using and which ones I'm not using. So 7, 3, 5, and 2. All right, now we're going to do the same thing to 720. 720 gets split into 72 and 10. 10 gets split into 5 and 2. And 5 and 2 are prime, so we would stop there. 72 gets split into 2 and 36. 2 is prime, we would stop there. 36 gets split into 2 and 18. 2 is prime, we would stop there. 18 gets split into 9 and 2. 2 is prime. 9 gets split into 3 and 3. 3 is prime, so we would stop there. So all the circled values are all prime factors of their respective numbers on top. So what do we do with them? Well, what we're going to do is we're going to multiply the prime factors each number has in common. All right? So for 210, we have a 7 as a prime factor. 720 doesn't have a 7 as a prime factor at all. So we can't use 7 to find out what the GCF is because they both don't have it. For 210, we have a 3. For 720, we have 2 3s. So they both have 1 3 in common at least. So we're going to multiply that 3 one time. So 3. 210 has a 5. 720 also has a 5. So they both have 1 5 in common. And because they both have 1 in common, we're going to multiply that 5 one time. So times 5. 210 has 1 2. 720 has 1 2 3 4 2s. So both numbers have 1 2 in common at least. And because they both have 1 2 in common, we're going to multiply that 2 one time. Times 2. And that product, the product of 3 times 5 times 2, is the GCF for 210 and 720. So 3 times 5 is 15. 15 times 2 is 30. So 30 is the GCF for 210 and 720. Right? One other neat trick that's also helpful for problems like this is that when you do the factor tree, if they don't have any common factors at all, the GCF happens to be 1 because typically it occurs when you are doing the factor tree for 2 numbers that are both prime numbers. So let's say a 7 and a 5. When you can't split them any further because they both have only 2 factors, 1 in itself. And because between those 2 values, 7 and 5, they don't have any common factors, the GCF between them would just be 1 because every number has 1 as a factor. So the GCF between 2 numbers, if they don't have any common prime factors, would be 1. So that's also helpful for a problem like that too. Now the lowest common multiple. So to go about finding what that is, you would do the factor tree again. So since we already did it, we're going to, for these 2 numbers, 210 and 720, I won't do it again. But we have it right here. And what we're going to do here is a little bit different from what we did for the GCF. To find the LCM, what you have to do is multiply the prime factors that appear the greatest number of times on either side.
What in the world?
So I know, sounds weird, sounds crazy, sounds bizarre, but allow me to illustrate it for you so that you know exactly what I'm trying to say. So what I would do is split the 2 sides like this, 210 and 720. So split it down that way. And we're going to use all the prime factors that appear, but we're going to use them, the ones that appear the most number of times on either side. So we'll go through each prime factor to show you how that works. So for 210, we have the prime factor 7. For 720, it does not have a prime factor of 7. But the most number of times it appears on either side is 1 time. Because 210 has 1, 720 has 0. So because it appears 1 time, we're going to use that 7 and multiply it 1 time. So 7. So for this 3, 210 has 1 3. 720 has 2 3s. So the greatest number of times we see that 3 on either side is twice. Because it's 2 times over here, but it's only 1 time over here. So the greatest number of times, not the total number of times, but the greatest number of times we see it on either side is twice. So we're going to multiply that number twice. So 3 squared. For the 5, 210 has 1 5. 720 also has 1 5. So the greatest number of times we see it on either side is once, even though they both have the same number of 5s. It appears 1 time on either side, which is the greatest number of times that we see it, which also means we're going to multiply it 1 time. So times 5. And 210 has 2, or 1 2. 720 has 1 2 3 4 2s. The greatest number of times we see that 2 is 4 times. So we're going to multiply that on either side. So we're going to multiply that 2 4 times. So times 2 to the 4th power. Okay? And in this instance, this product will be the LCM. So this is going to be a pretty big number. 7 times 3 squared is 9. So it's 7 times 9 times 5. 2 to the 4 is 16. So it becomes this. Let me do the math real quick. It's 63 times 5 times 16. 5 times 16 is 80. So 63 times 80. And 63 times 80, 48, 2. So this would be 5,040. Right, so 63 times 80 is 5,040. And that number would be the LCM for 210 and 720. Right, and a neat trick that also applies to this concept as well is that when you do the factor tree for the LCM, and again, if they don't have any common prime factors at all, then the LCM would be to multiply these two numbers together. All right, so in school, I know sometimes the teachers teach you that if you just multiply these two numbers, that would be a common multiple. While that's true, your teacher's not wrong about that. It doesn't always produce the lowest common multiple. The lowest common multiple is actually more important because when it comes to adding and subtracting fractions, you won't have to reduce at all when you get to the final answer. You do all the reducing by finding what the lowest common multiple actually is. So in this instance, if you were to multiply 210 and 720, that's an even bigger number. That would be 210 and 720. That's like 151,200. 151,200. So this number would be a common multiple for these two, which we could use for a common denominator for a fraction. But then you have to reduce this into that, the 5,040 in the end. And if you're not very good at reducing fractions or numbers, this might be a bit of an arduous task. So why not just find the lowest common multiple right off the bat and don't have to worry about reducing in the end because you've already done it. So when you do the factor tree for these two numbers and you're trying to find the lowest common multiple, if they don't have any common prime factors at all, then the lowest common multiple would be the product of the two numbers you started out with. And again, that tends to occur when those two numbers happen to be prime numbers. If this were a 7 and that were a 5, because 7 and 5 have no common prime factors at all, then you would multiply 7 and 5, and that would be the lowest common multiple for 7 and 5. So it just makes sense. So that's how you go about solving the GCF and the LCM. Thank you. I appreciate that. All good. All right. So, all right, everyone. That's another demonstration of what Intelligent Black Society is all about. Don't forget to like, share, comment, and subscribe to our social media pages. We've got Facebook, Instagram, and YouTube. And always remember that the two most important days of your life are the day you were born and the day you find out why.